Alright, so we're moving on into Chapter 6, Lesson 2. And in Chapter 6, Lesson 2, we're going to be looking at the second thing that all animals have in common. So in animals, we talked about how they have to get food. That was the first video. This one is about how we get oxygen. Remember, all animals need oxygen in order to survive, where plants need carbon dioxide, the byproduct of what animals give off. So first thing you're going to do is you're going to have your books open, and I'm going to come around while you're starting this video, and I'm going to check for your assignment. You have 4 questions that you need to fill out over the weekend. Give you 4 days to do it. It's a quick and easy grade. So have your book out, and I'll come around checking it while you're watching the video. So in our book then, it talks about oxygen and oxygen exchange and the difference between oxygen and cellular respiration. And a lot of times people that know a little bit about science, a little bit about health, they kind of put those together. But it's the same type of concept, but it really is a different thing. When you and I are breathing, we have our lungs, and that's what we use to get our oxygen into our body. We have a lot of different things that work together. But our lungs is where the oxygen comes in. So I'm going to breathe in the oxygen, and then I'm going to exhale. I can't inhale and exhale at the same time. So I take a big breath in, and I get my oxygen. Now, and all of this gas around us known as air, it's not all oxygen. Actually, the smallest portion of it, one of the smallest portions of it is oxygen. The largest portion is nitrogen. Our body doesn't recognize nitrogen gas inside of the air, so it just goes into our lungs and goes right back out. So it's one of those things that when I have an exhale of carbon dioxide, I'm not just exhaling carbon dioxide. It's all those other gases that are in the air that are in my lungs also. They expel or go out when I exhale with the carbon dioxide. However, the key point to us being able to breathe is I have to breathe in oxygen so my body survives and exhale carbon dioxide. All those extra gases are just extra. So that's just a tidbit of information for you on the side. The cellular respiration seems very similar in process, but it's in the cells. So this happens in the lungs. And basically what happens is when I breathe in the oxygen, it goes into my lungs, and then my lungs insert it into my blood as it's traveling by. But then my blood also spits out carbon dioxide into my lungs. And that's how I'm able to exhale. So it's basically like a subway station where people are getting on and off, on and off, on and off constantly. The oxygen gets on into the blood and travels around and is used. The carbon dioxide gets off and then leaves when I exhale. In my cells, cellular respiration works the same way. I am low in oxygen inside my cells. So when the blood gets to the cells in my body, where my muscles are, where my skin is, where my hair, my bone, all of that, then I'm going to drop the oxygen off. And as those cells are working and living and doing what they're supposed to be doing, they're creating carbon dioxide. So the carbon dioxide then gets onto the blood bus, and it takes it back to my lungs where I exhale. Cellular respiration is kind of like the idea of Black Friday. I've been to Black Friday shopping one time, and I swear I'll never go again. It's too crazy for me. I don't like crowds. But people will line up outside of the stores on Black Friday all the way around the store. I've been to one Target where it literally went all the way around the store. The end of the line was here, and here was the front of the line, and it was a super Target, so it was ginormous. But that's all the oxygen wanting to get inside of my blood. But it can't get inside of my blood until some stuff leaves. What are these people waiting for? They're waiting for that gate to open, and then they go crazy running around the store grabbing all the things that they want. So when I look at my cells, it's the same kind of idea. I have all of this oxygen lined up, wanting to get into the cell. But before it can go into the cell, it has to have room. Carbon dioxide has to come out. So let's say the carbon dioxide came out. Now there's room. Notice that the cells then flow into the cell. It's used up. It's part of the process the cells use to create the sugar that it needs in order to be healthy and do its job. It changes then the oxygen when it mixes with sugar into carbon dioxide. And then I got all this carbon dioxide floating around in there, and it has to do what? Well, it's going to have to leave. When the carbon dioxide builds up, it's got to exit out of the cell. When the carbon dioxide exits the cell, I've got room. If I have room, I just continue the loop. If there's room, oxygen comes in, it's converted to sugar and carbon dioxide. The carbon dioxide's built up, it wants to go out, it leaves, which allows the oxygen to come in. It comes in, gets used, changes into sugar, carbon dioxide. It builds up and wants to get out. It leaves, it allows the oxygen to come in. The process happens over and over and over again. As long as our cells are healthy and alive, that process is going to continue. Cellular respiration. The process of going in when there's not enough oxygen into the cell, and then the carbon dioxide pushing out because there's not enough carbon dioxide in the blood, is called cell diffusion. It diffuses, so it tries to make an equal amount at all times. So when I start with my questions in my book, I should be around by now, hopefully, checked off if you did your work or not. 1A says, what does breathing do for an animal? Well, that's pretty simple, I would think. Breathing takes in oxygen and it gets rid of my carbon dioxide. If I have my oxygen inside of my body, I can make the food that my cells need in order to be hungry or in order to be healthy, and I continue to be healthy. If I only have carbon dioxide inside my body, I'm in trouble. I can't survive. Carbon dioxide is a toxic gas inside of my body, and so I have to get it out. And the only way I can get it out is by pushing it out of my lungs. Why does oxygen diffuse into the cell? Well, it diffuses because the cell itself is low in oxygen. How did it become low in oxygen? Well, it used it. It's kind of like our bellies. When I eat, I'm full. But as the day goes along, all of my cells are working on the inside, and my belly begins to get a little hungry. So now I no longer have food inside my belly. So what do? I put more food inside my belly so I can continue to work and be healthy. Oxygen is the same way. There's not enough oxygen inside the cell, so it diffuses into it, because as it's using it, it changes it to carbon dioxide, and the carbon dioxide has to get out. Why does it diffuse? Because the cell is low in oxygen. So when I look at the respiratory systems then, when I go to page 219, then I see there are three basic ways in which we get oxygen inside of animals. One is through skin. Talks about amphibians. Worms are the same way. Their skin does most of the breathing for them. They have pores inside their skin. So a lot of times what you'll see is you'll see frogs that are sitting in the water or in a mud puddle or something. They have to stay moist, number one. But number two, there's oxygen inside of the water, and their body will absorb it through the water quicker than it will through the air. The reason that is, if you've ever held a frog, its top layer is kind of rough, right? So if you think back when we talked about plants, the top part of leaves, they don't do the oxygen exchanges. They have that cuticle, that waxy substance on the top that keeps the gases from escaping. There's some oxygen and carbon dioxide exchange that goes through the top layer of their skin, but because it's so rough and the bottom is so smooth, well, the smooth section easily exchanges those gases. Will easily exchange the oxygen out of the water and get rid of the carbon dioxide. So most of it on a frog and a toad, when their belly side is softer, is going to allow the exchange to flow even easier. On their skin then, we have these pores, and these pores pull the oxygen in through the water, and it separates the oxygen and then gets the carbon dioxide and sends it back through the pores of the skin. And the same idea when I talk about fish and I talk about their gills. So once again, these are not the inlaid gills inside like the side of a shark or the rays. These actually fold out in pockets. And you'll see them actually folding in and out as they're spinning or letting the water really cycle through their body. When you look up close at the gills, they have these little fine fibers throughout them. And what those are is those are blood pockets that are absorbing the oxygen out of the water and then just letting the rest of the water pass through. So the water goes in through their mouth and over their gills. and over their gills filters out the oxygen that's in the water naturally. And the rest of the water just passes right on through the back of their gill. With lungs, this is what your and my lungs look like. They're moist, they're soft, they are expandable. This is what we call our trachea and our bronchial tubes. So they go from our throat when we breathe in into our lungs, and we have a process of breathing. But what happens when we breathe? If you take a big breath, you ought to notice that your chest cavity expands. We'll get into bones and how the front part of our ribs are actually cartilage, which means it's a softer bone and it allows it to expand and shrink. I have a muscle here called a diaphragm. And when I breathe in, it pulls my diaphragm down, which allows my lungs to be bigger. And then when I exhale, my lungs shrink, my chest cavity gets smaller because of those flexible cartilages, but my diaphragm then, that's that muscle underneath, pushes up on my lungs. I exhale all that carbon dioxide that my body has used. So I inhale and then I exhale because I have lungs. But lungs can look very different according to different critters that we have. So the ones that are mentioned in your book as you read them for your assignment, one is called tracheal tubes. These are tubes that do an exchange for the animal, but it's not in their throat and in their mouth like we would think. Tracheal tubes are on our insects, and they are in they're underlined and they're parts of their body. So I have all of these little openings that act like their lungs, like yours and mine do. So they have like several openings to breathe through, or maybe nostril holes like you and I, but they have several. We get 2 and 1 mouth, which makes 3 openings. In the bee, it's the same way, but they're more on their backs. But they're just constantly inhaling and exhaling. So if you ever watch these critters, you'll actually see their bodies opening and closing, opening and closing, opening and closing. And all they're doing, when they're expanding, they're taking in the oxygen. And when they're decreasing in size, then they're exhaling. Another insect that has another type, those are called book lungs. And so when I look at arachnids, they have these layers of lung-type things inside of their bodies underneath their abdomen, right here. So there's a little ledge that acts like the opening for them to breathe in or suck in oxygen right here at the back of their abdomen. And then it fills up this gas pocket, and then that's where they get their oxygen from. It doesn't come in through their mouth like we would think with most animals. When we talk about lungs then, actual lungs, we have 3 different types that are listed in our book. This picture's from your book. When you look at the amphibian lungs, they're actually very small. So salamanders, newts, frogs, toads, they're very small. And because they're very small, they can't get enough oxygen to support their bodies. That's why they have to start breathing through their skin. That goes back to the frog that I showed. The underside belly is going to do a lot of respiration through the water, and then its back has some smaller pores, and it does cellular or exchange of gases, respiration, through the top layer of its skin. The more we get into higher level of organisms, reptiles, and then especially mammals, then we have highly developed lungs. And the more folds that there are, the more oxygen we can get. The more efficient that they are, the more they spread out the oxygen throughout our bodies. But one animal that's really different than us is a bird. A bird, because it flies and it puts forth so much energy as it flies, it actually gets like these extra lungs. So they have their main lung here in the center, but it also divides off into extra lungs, extra pouches. It has a top and a bottom. So most of their internal organs is actually these air pouches, because they have to use so much energy in order to fly that they have to have extra oxygen. So when they breathe in and they expand, they get all of this extra air stored up in like these balloon processes that then act as their lungs. They exchange the oxygen and they bring in the carbon dioxide and then they exhale. So especially if you have little birds and you watch them, they breathe really quick and really fast because they have all of this extra air coming in and all that carbon dioxide that's going out. It's a very quick video and a very quick lesson, I know. You should have plenty of time to do your assignment. So if you have any questions while you're doing it, please come and ask. Make sure that you're reading your book, finding the answers on the pages that I've told you where they are.